fine. We're doing well. It's just that we need to cram so much things on just a little bit of time left. But yeah, we're doing good.
You guys in the middle of finals or
Right,
done
right.
with them?
I'm with the team.
So is everybody here that you want to be
Yes.
here? All
I
right.
think we should start now.
Okay. If you wouldn't mind, introduce the team to me.
All right. Um. Good afternoon. I mean, good morning once again. Good afternoon to you. I'm Irec, the current student team lead of the Ateneo de Davao University rugby team from Davao City, Philippines. And we're competing under the 30,000 feet commercial off-the-shelf all propulsion type. And we have our rocket here, Lab, which is around a 10-foot rocket, and it's running at around. It will run for using an M4000W uh, motor from Irec, and I think they want us to run through the rocket from top to bottom. Is it okay?
Yes, I would like to meet the team first, if that's
Ah,
okay.
okay, okay.
Introduce
Team
them.
first. Okay, here's Franz Guevara. He's our uh the lead last year, which was Seaball. And then here we have Azzy, avionics lead. Hi. And
Right?
then here's Angela, the payload lead. And then who else? How about the others? Here's also Neil, the current recovery lead. And then the others as well are also here. And there's Sanohas, who is, I think, just left. She just left, but I think she'll just come back. But she's our uh, structures lead.
Okay. Um, yeah, before we start, I just made a couple notes somewhere here.
All right.
Um, how did your team do last year?
Um,
Hi, Bao.
Hi.
So, well, last year it's actually our first time for the IREC, or previously
Okay.
Space North America Cup. We did 10K last year, same costs, and that was also our first time. The difference basically this time is we have much more experience now, and we're also running with a payload. Last year we only flew with a boilerplate, like mass to you know move the center of gravity. Now we are actually doing it with a new payload, a new working payload, and yeah, we have a new subsystem for the payload.
Okay. I'm sure that it helps a lot to have you on the team with the experience being there last year because there's so much to learn and know and understand.
it really did.
Well, great. Okay. Yeah, if you want to start with the aft end, the bottom of the rocket, and we'll
All right.
move up.
Um, let's start with the aft. Can we have the camera ready? And then the fins. The fins. Ate Maris. Maris Sanohas will take over for the structures.
Okay.
Good day, Bob. Not sure what time it is there, but I'm Marise. I'm the structures lead for this year's competition. I was also there last year as
Oh,
a
good.
member. So, so we're not starting from the top. We're starting at the bottom.
Oh,
Okay,
you want to start from the top? It doesn't matter.
okay. I think we should just start at the top.
Okay. If you're prepared for that, let's do that.
Okay, so starting at the very top, we have our aluminum tip. It's machined to fit inside of our nose cone. And uh okay, can you twist some more? Okay, so As you can see there, there's a slot for a 5/16 inch threaded rod. So that would connect to the bulkhead inside of the nose cone. And yeah, okay. Next, let's proceed with the shoulder part. And also for the fabrication of our nose cone, we use a split mold method for the making of it, since we do not have a lathe to go for a positive mold version of it. So, can you guys remove the nose cone, please?
Sorry, I'm going to move my
Uh,
camera down so you can look at my belly because that way I can see the screen.
okay, so anyways, so that is the shoulder of our nose cone. That's around 18 centimeters. So that would be housing the payload of our team uh, this year. And the the one they're holding is actually the payload bay. Can you guys?
Okay.
Yeah. So that's the payload bay, and then beneath
And what is
that
that
would,
made from?
sorry,
What is the payload made from? The payload bay, I
um,
guess.
I believe it would be in aluminum. Am I correct?
Okay. That's what I was going to guess. It didn't look 3D printed. That's nice.
Actually, that's 3D printed because.
Oh, that's too bad. No, that's okay.
Okay. Anyways,
All
so
right.
beneath that would be another bulkhead, and that's where we're going to be attaching our eye bolt for the main recovery system. Yeah. So that's
Uh,
all for the nose cone
we have
section.
the actual drawing of the um payload. Do you want to see it, Bob?
Does the payload stay attached?
Yes, it will remain attached. It will be just to better present it. I'll just wait. Transition starting. Window. There's the solid.
So for our payload, we don't have uh, I mean we have the electronics and stuff, but it's the structures are still in the machine shop, and we're
Okay.
waiting on. But if you can see, can you see our screen right now?
Yes.
Oh yeah. So this is the SolidWorks assembly of it. So it's just a cylinder type, and we could go for the CubeSat model from the payload challenge, because there's not enough space in the minimum diameter rocket for a payload for a CubeSat shape, apparently. So we just opted for like a cylinder type shape here, and that's that. Our payload is, if you read our technical report, it's just the air quality monitoring payload that monitors different types of air molecules. And
Okay.
So it will be knotted here, here, and on all sides of the threaded rod, just to secure it. And then on the forward end of the bulkhead, where this payload will be mounted, it will be, I mean, on the aft end, sorry, it will be where the eyebolt's gonna be.
Okay. How is that armed or turned on?
oh, here we go. So we're just gonna use a pull pin switch, and
I'm
Okay.
sorry.
I'm sorry, there's a flag ceremony. If you can hear that.
That's all right.
Anyway, so in here there's just a open switch that will go in through the go in the nose drum section. This is similar to what the avionics will show later, where they also have open switches. So that's how we arm it.
So I'm just curious. It seems like unless it's a a really tight fit going through that coupler, there's room for it to wiggle. Is it possible to mount like a 3D printed or a brass
Oh
tube?
yeah, yeah. I stopped in the this assembly here, but there should be a like a hook cylinder over here. So
Something to guide. Okay.
oh, so that's right there. Yeah.
All right. That looks
Okay.
good.
That's just
All right.
these gray things are just the sensors, and just we just modeled them here. So yeah. It's
And
supposed to be inside.
the batteries are well secured in the 3D print for the G
Yeah.
forces, both positive and
Yeah,
negative.
there's gonna be a mount made for this specifically, and additionally, we're gonna have zip ties on it, and
Okay.
to be sure.
All right, good. All right, that looks fine to me.
Now the other
Um,
components will be screwed on. So, yeah.
okay. I am curious about the eye nut or the eye bolt at the bottom of that
Ah, the eye
bulkhead.
bolt. Okay, so it's not showing in the book. The book it's supposed to be on the bulkhead on the bottom side, but it's not in the model. But maybe we can show you the bulkhead later. But yeah,
Okay.
so the bulkhead for the nose cone will be connected by threaded rods here, and then that's where the eye bolt will. And then on the other side, there's a bulkhead that connects to a threaded rod from the nose cone tip. So it'll be connected by a threaded rod and from the nose cone, and then bulkhead to threaded rods on the payload, and then bulkhead, and then uh, eye bolt after.
So I just want to make sure that the eye bolt is secured somehow so it can't unscrew if the parachute starts to swivel with it.
Oh yeah,
Either
yeah.
some,
Oh yeah, yeah, yeah.
okay, some thread lock or something.
Yeah, Loctite and
Right.
Right.
yeah.
Okay, good. All right. I'm fine with that. Oh, have you guys started the recording?
Yeah, yeah, we started the recording already.
Okay. All right, good.
Okay. All right. Now, can we continue with the rocket itself?
Yes.
All right, Ate Maries.
Yeah.
Okay, so that's the nose cone's side. So let's proceed to the main.
Okay.
Okay, I'm waiting for the camera. Anyway, so can you guys zoom? Wait. Okay, so for our main main airframe, so that would house the main recovery system, and I think the representative for the recovery system can walk us through the mechanisms.
Okay. I'm not hearing anything.
It's just there,
Oh, I'm
ready to
sorry.
know next.
Can you turn on?
I'm sorry, sorry. Okay, hear me now?
Yes,
Yes.
yes, go ahead.
Can you hear me now?
Yeah.
Yes, yes. All right. So, okay, let's do this again. So, this is our current main assembly. So, we have our main and drogue. There is our shock cords. How we shock cords. These are connected
Yeah, I'm sorry. We're having some
to our nose cone, and then our shock cord that we're using is a 1/2 inch tubular Kevlar, which is used by lots of teams as it is fire resistant and so is very strong. And currently, our main is in the burrito form. So for our parachutes, they're actually fairly similar in design to
I'm sorry,
parachutes
it's
since
breaking up.
our parachutes are actually made
Wait,
in-house.
stop.
So,
Can we do it again? I'll just have to bring the. Just a
Yeah,
second.
I'm sorry. It's just breaking
Can
up
you hear
and
us?
yes.
Can you hear us properly? Sorry.
Yes, I can.
All right. Yes. Are we good?
Yes.
All right. So where do I start? Everything?
So,
Okay,
okay,
let's
with
start.
the shock cord. So
Okay.
the drogue and the main come out of the same compartment at the same.
Uh, no. The main parachute comes out from the upper section of the rocket, and the drogue comes out
in the lower section. And I'm just showing
Okay.
you since this basically are the two same parachutes but in different diameters, but they have the same construction methodology. So for our main and rope, they're actually made of a 1.1 ounce ripstop nylon. And then our shrouds, we have 12 shroud lines. These are made of line, which is rated for around 400 pounds. And the methodology on how we were able to create these parachutes is actually from the Naka Rocketry. And Naka Rocketry is a reliable source. So we just followed their methodology in developing the parachutes. And similarly with the materials, these are the materials used by other COTS manufacturers in creating these parachutes. So our parachute also has a swivel line so that it's able to untangle itself, and we're going to connect it to our uh, shock cords using the quick link, the M6 quick link.
Okay. That's good.
Yeah. And also our shock cords are from Wildman, so these are truly tested, so they're gonna be good.
Yeah, that looks solid. Yeah.
Yeah, I guess that's about almost everything for our main recovery side.
Okay. So just so I know, drogue comes out below the coupler and the main comes out from the nose cone.
Yeah.
Yes.
Okay, good.
All right.
Can we move on to the next part? Avionics. Okay. All right. Let's proceed with the avionics.
Okay. So I think we've gone over the nose cone and the nose cone extension. We'll head over the coupler. This coupler is straight from Wildman Scots, and this is where we house our avionics. Our avionics lead, Azzy, will run through how we're gonna work with the electronics part.
So this is our avionics LED, and it's pretty typical, and it's pretty tight because of the minimum diameter. So we have Esra as our primary flight computer. Then we have Blue Raven as our secondary, and Blue Raven doesn't have telemetry, so we're gonna have a redundancy on our GPS coordinates using the featherweight GPS tracker right here. And it's also using a battery that's manufacturer provided. But I want to confirm this with you as well because this is LiPo. This is LiPo battery, but it is manufacturer provided. So
That's
this
okay. That's good.
okay. Okay, and then gonna be using the same as payload. It's gonna be a pull pin switch mechanism to turn them on. So we have right here the switches, and then we're just gonna have a pull. So this is
Okay.
3D printed. And then our batteries, it has a battery. We've 3D printed a battery holder as well. And then it has holes in it for zip ties as well. So we're gonna secure the batteries with zip ties along with a Velcro tape. So this is Velcro tape. And then that is made out of PETG filament, but this I think this is just 20% infill. But for the actual competition, we'll 3D print it again at a higher infill.
Okay. What percent infill for the competition?
I think it's
More than
recommended
20.
100%, but I don't know. Can it be lower than that?
Yes, I think, I mean, 60 or higher should be fine.
60% is fine. So yeah, I think that's it. And then is our drogue ejection well. It's 18 centimeter height. And then I think we're just gonna pack the drogue parachute in between these parts. And we also test this. Um, and then this is our main ejection wells.
Okay. And how many grams of black powder are you using for the main?
For all of them, we're using 2.3 grams for the primary charge, but for the backup charge, we'll increase it by 1 gram. So it's gonna be 3.3 grams.
Okay. Have you done any ejection testing?
Yes, we did.
Yes, we did. With
Okay. Because I'm concerned with the length of those. It seems like it's more like a rifle than a. I'm not sure why they're so long. They could be shorter.
yes, because that's recommended by our mentor Noah because this is what they did last year. It was also long. I think theirs was
Hmm.
like 15 to 17 centimeters as well. So they said that it would work, and we did it with 2.3 grams, like right here in our
Okay. Okay. I just haven't seen that. So
Can we show it? Do you want to see it? I'm sorry. Do
no,
you
I
want to
just
see it?
haven't seen ejection wells that length to diameter.
Ah,
Okay, okay, let's see. Yeah.
I think the reason behind it is that the design of a longer well works much better for
Higher
the
altitude.
higher altitude. So that's the
Oh,
reason.
okay. Yeah, you have to confine the black powder to get it all to light. Um,
Yes.
what keeps the black powder in?
What?
Um, we have a wadding. So it's the
One more.
tissue, diba? It's tissue and baking soda. So
Okay,
50% of this would be like the black powder, then another 40 to 50% is just the wadding.
okay.
Next. Yeah, so can we move on?
Yes.
all right.
Right.
Philippines, can you proceed with the app?
I think no, I present now. So as with the aft of our uh, rocket, this is the booster section.
Okay.
Maurice, can you proceed with the presentation of our aft and the fins?
Okay. Can you guys zoom out to see the overall length of, just so Bob can see how long the aft is? So the aft is around 2 meters, which is a concern for me since I'm not sure if the coupler can join both airframes well, since we're still gonna cut the coupler.
Oh,
So
okay.
that's something I have to raise also. If you think we should just keep the coupler length or cutting it would be fine.
So why do you want to cut it? What's your thinking behind that?
Flight ops, can you respond?
We have it at around uh 18 inches. Coupler, which is at around 46 or 47 centimeters, if I'm correct. The reason is, in our original design, we have it at around 30.3 centimeters. So we're not that sure if
Uh,
it's that. Oh my God, I'm sorry.
no, it's
Hello.
hard to hear when the chairs move.
All right, I'm sorry. So, going back, our original coupler is at around 45.7 centimeters, and then the one that we have in our open rocket is at 30.3 centimeters. But I think we've read it at Rocketry Forum that the longer the rocket, the longer the coupler should be. So our concern is, should we still proceed with our 30.3 cm coupler, just so that we could follow our open rocket simulations, or um, have that safety margin.
So my thoughts on that. The distance, because you have a 2 meter um, um, a thrust section, the distance between the top of the motor and the bottom bulkhead there seems to be quite large for 2.3 grams of black powder. If you cut the coupler shorter, you're going to make that the distance between the top of the motor and the coupler bulk plate even shorter. I don't think your airframe is is, I'm sorry, I'm looking for it on your sheet so I don't have to bother you. Is that 98? Is the motor 98 or the airframe 98?
Yeah, the motor is 98.
And the airframe, what's the
Airframe is
diameter?
around 10.2 centimeters
Point five.
Okay.
with
Um,
98 mm inner diameter.
so I could convert this to centimeters, but my rule of thumb for black powder charge, so for an airframe, approximately 100 millimeters, is 1 gram of black powder per 11 inches. So what's that, like 300 or so centimeters? No, um, per 28 centimeters. 1 gram of black powder per 28 centimeters between the top of the motor and the bottom of the coupler bulk plate.
All right. We'll take that into consideration.
I mean, unless it's a mass, are you trying to reduce mass, or I would just leave the coupler the length it is,
All right. Because
because then
actually, quite concerned with the space allowance for the parachute bay also. But I think we'll just,
okay.
I think we can just work it out. All right. Can we proceed with where we left off? At the
Yeah.
Marie's.
Yes, go ahead.
Okay, so mm, after that would be. Oh, also, I haven't talked. Have you guys talked about motor retention or no?
Not yet.
Not
Okay,
yet.
so for the motor retention, we purchased an aero pack forward retention. So can you guys show Bob the aero pack? So this is the motor retention. So that would be at the forward end of the motor, and that's also where the drogue parachute will be connected there. And
Okay.
also, the secondary retention would be the hardware of the motor is bigger than the airframe, so it wouldn't, it's just gonna push through the walls of the airframe there. So, is that sufficient or?
I'm not sure I followed that. So that motor retainer that you have there, um, there's an eye bolt or a loop at one end, and the other end looked like it had a threaded rod. What does that thread into? Does that thread into the top of the motor case?
Yes, it does. Like,
Okay.
okay.
And what prevents that from backing out of the rocket when the ejection charge fires?
So, what our mentor recommended is we're just gonna have to use an epoxy to secure it inside. Or do you recommend also other methods?
Um, I I don't recommend that method. No. Uh, so since that attaches to the motor, um, is there a way to fasten that that red component to the airframe with screws or even large plastic rivets to keep that from moving backwards?
Um, will thick epoxy work, or we need mechanical fasteners really?
So you do thick epoxy, and then that motor is permanently mounted in the rocket
Something like that.
motor
Yeah.
case. Um, uh, I don't like the advice you got for that. That's
Hello there. I'm so sorry. I just joined in. I got the time zone mistake. I'm Noah Miranda. I am the five record slash mentor.
I
Um,
know.
currently, yeah, sorry, I'm outside right now. I misread the time zone as May 16th, but it's the 15th. So
Oh,
I'm currently out right now. But from my understanding, the motor was not meant to be permanently bonded. It's the retainer itself. It uses like an Aeropack style attachment method. That was to
okay.
my understanding. Um, that's what my team used last year at the Spaceport America Cup.
Okay. Yeah, that's a different story. I don't know. So the airframe's fiberglass. I don't know if the aluminum has any texture to it, but you basically don't want something that's very smooth because that the epoxy needs something to grab onto. So I would sand or even use a Dremel tool to score that up so the epoxy has some high and low points to attach to. Does that make sense?
All right, all right.
But
I,
yeah,
I
I'm
did
okay.
I did advise them on using some sort of a hydroxide etching, like a sodium hydroxide lye drain cleaner to sort of chemical etch the surface of the aluminum. That's worked with
Okay.
my team in the past for a bond, but sanding, abrading, and IPA wipe seems to work well. Sorry for the noise in the back.
You're good. Okay, thanks, Noah. That's helpful. So yes, I'm fine with that motor retention.
All right. Can we? I mean, if ever we're gonna epoxy the motor retainer, do we still have to do the rivet thing that you advised, or that would
No,
work?
no,
Okay.
that can work in place of.
All right. Understood. Can we proceed, please?
Yep.
Okay, so after that, I think the last component would be the fins. Can you guys? Okay, so there's our fins, but it's not yet adhered to the airframe, particularly because we do not have yet a good epoxy to use to adhere the fins onto the airframe, since there are airline restrictions that um, stops us from purchasing good epoxies. So our option right now is only the only available option for us is JB Weld, and I'm not sure if that would work fine. What do you think?
Um, for that class rocket and motor, I would like to see something a little bit more robust or stronger. I don't have anything against JB Weld. I use it in my L1 rockets. I don't have a lot of experience with the different epoxies. When do you arrive in Texas?
June 5, right? Or June 6.
Or in June
Okay,
6th?
Okay, yeah.
so I don't know if you can make arrangements um, to meet someone, a vendor, or even another team with the epoxy you're looking for. Would that give you enough time to attach the fins like you want?
I think so. Uh, yeah.
Noah, you have any thoughts on that?
Yes, so I have had previous experience with the steel reinforced JB Weld. It's the same stuff that you use on Aeropack retainers. However, my initial suggestion uh, was to use some sort of strong epoxy like Proline, DP420, the Scotch weld. But like they said, the export control and getting it into an airplane is very much of an issue. So I think if bonding the fins was not an option in America, if they had to do it ahead of time, I just suggested some use of fiberglass strand as like a filler to give it some sort of structural reinforcement. But I think that would only work with a thinner epoxy. So the options are unfortunately quite limited here.
Is it possible that they attach the fins and then when they get to the U.S., look for a different epoxy and maybe put some larger fillets on with a stronger epoxy.
I do think that's a very sorry. Can you hear me right now?
Yes.
I do think an option that they discussed. Um, Fill it like a root bond with like a 5 minute epoxy, just so it doesn't get knocked during transport, and then finalizing the fillets with some sort of structural epoxy can work. So to reiterate, sorry if I was very unclear. But essentially, to tack the fins, they use some sort of 5 minute epoxy, something that's stronger than super glue. And then
Yeah.
when they get to the States, they use a structural epoxy such as EP420, Proline, etc.
Okay. Yeah, I would I would recommend something like I like JB Quick. It sets in 6 minutes, and I've just gotten very used to how to work with it. Um, I forget there was a point I was going to make, and now it has escaped me. But yeah, I would put some decent fillets on again. Make sure the surfaces are well roughed up so that the epoxy has something to grab onto, and then I think secure it as best you can for transport. And I think you can use some better epoxy when you get to the States. Um, I don't know that I have any of the Perline or other ones recommended, but I think my experience is the rocket community will fall all over themselves if somebody needs an extra igniter or duct tape or masking tape. And hopefully you can find somebody with some epoxy.
My team will be present, so if that is the option, if that is the course of method, yeah, do the JB weld, the quick weld, the quick JB weld, and then yeah, stronger fillets when they get to the States. My team can be we can order some epoxy for you. I cannot bring it to the Philippines because I
No.
mentioned to them that I was going to visit them. I
Oh,
was going to visit them I'm actually visiting them in a couple weeks.
oh
Um,
wow.
so I will be able to inspect what they have. But yeah. Apologize about the noise again. I'm at a race right now, so I
You're
just finished my race. So
okay. You're good. Appreciate you dialing in, Noah. Okay, so we have motor retention. Talk to me about shear pins.
Uh,
Are you using shear pins at all?
for the shear pins, we'll be using a 2-56 nylon shear pin coming from, where was it again? Apogee? Was it from Apogee? No, shear pins. We'll be attaching it. So on this, wait, I'm sorry, can you hold? This part, forward mounting this one with three M3 screws and three coupling nuts also. So this coupler goes with this forward, those three M3 the M3 bolts, I'm sorry, that I mentioned earlier. And then for this other kind of the coupler, we'll also be attaching four 2-56 shear pins. So four here and then here it's the yeah, it's right. Apogee components, shear pins, we have plenty of this. And then another on the other separate here in the payload section will be also screwing, mounting for 2-56 shear pins. So,
Okay.
um, all right. Now, we also have our rail guides here. This one is still 3D printed because we're still waiting for the actual machining. But
Okay.
this is a sample of the 1515 rail guide that we'll be using since we need 17 feet of lunch rail length. So this will be the actual size or the scale of the rail guide that we'll be using. One will be mounted just near the center of gravity, around uh, I'm sorry, 140 centimeters from the app. It's just here, and then it's just gonna be here, and then the other would be far, uh, on the far side of the motor. I mean, sorry, on the airframe. Now, same, just as what Noah said earlier, we'll be using rigorous surface preparation for this one because we'll be using aluminum. Sorry, using aluminum as material for our rail guides, and then attaching it uh, to a fiberglass material. We need to maybe score it further so that it could really attach using our epoxy. You have anything else to say?
And what's the distance between the rail guides?
We have it at around 65 centimeter. I'm sorry. One, two, three. 1.8 minus 1.8. 135. It's 135 centimeters.
35 centimeters?
135 centimeters, sorry.
I'm sorry, say that again.
135.
Okay. So your off the rail velocity should be pretty high.
Right. It's at around 125 feet per second.
Okay. All right. I mean, I'd like the rail guides to be closer, but I think you'll be fine.
We just wanted it to be um just right above our center of gravity, just to make sure so that it could just hold the um the rocket right above the CG.
So the reason I bring that up, because I've had the experience where I had a rocket. It was a 3-inch rocket, a rail button at the very bottom, and one about a meter above it. When the first rail button clears, and it was launched on a VMAX motor, but when the first rail button clears the rail, if it's a windy day, it can easily pivot around that bottom rail button. Now you have rail guides. It could snap them off. Honestly, I'm not concerned about that, but that's why I bring it up.
All
I've
right.
seen teams come to spaceport with one rail button at the bottom and one near the top of the rocket, and that won't work. So you guys are okay.
All right. All right. All right. Um, I think that's pretty much most of the rocket. Do you still have Ate Marie's? Do you still have anything else to say? Or from Noah?
Hello. I think the option of fin attachment in the United States would work since we're also going to be epoxying the rail guides there since we do not want to risk using weak epoxy in the Philippines. So yeah, that's all for me.
Okay. So I think I'm good. I do have a couple. So one thing, you have a checklist. Make sure you have a checklist. The safety reviewers are going to ask you if you have one. Um, let's see. I don't remember talking about the arming suite sequence of your altimeters, and you have the pull pins. Are they? Please label them so you know which one is which. Um, and then I would arm your GPS first, even while it's still on the ground or still horizontal. But then you can arm the altimeters as you want to. Um, the other thing I would really strongly recommend is to assemble your rocket. Um, do a full up assembly, everything from the motor case to, I mean, you could do e-matches, no black powder, no energetics, but get familiar with it. You don't want to assemble your rocket everything for the very first time in the heat in Texas. Trust me on this. As many times as you can practice and review your checklist, update that as needed. It will help you when you get to Texas for sure.
Yeah, we got it.
Bob, I I have one more question.
Okay.
Um, how many screws do you recommend to attach the coupler to the nose cone section?
We're
So you
initially. Go
screw
ahead. Sorry.
through the airframe into the nose cone coupler.
Yes.
Um, well, it depends on what size. I would. Um, let's see. I'm trying to look at my metric equivalents here. I think. I think maybe four M5 type screws, but I am not a rocket scientist. So if you have some better calculations, I would go with that or go with what Noah suggests.
All right. I see. Um. Yeah.
Do you have any more questions or concerns?
I don't. I'm not very happy with the amount of information we're getting about the actual competition. I'll send you what little information I have about launch location. I'm told that there's no hills there. It's mostly hard pack with some low vegetation, and all the vegetation there will try to hurt you. Um, so, if you have heavy pants and boots, you might consider bringing those.
Did they say if the setup's gonna just if the setup's just gonna be the same as last year, where the setups where the tents are already set up for the teams, or um,
Yes, I've asked, and there are going to be the canopies, the large tent canopies that they had last year. Each team will get two tables, and I don't remember if they told me how many chairs, but the shade and the tables will be provided by Irec.
we would just want to ask, how early can we go to the launch site if it opens if the gates open at 6 a.m. How early could we arrive? At what time are we allowed to arrive?
So I don't know the answer to that. Irec has done away with um, the early flight bonus because it created such a headache. What I've been told is that the winds generally pick up in the afternoon. Flying in the morning is preferred. If you if your rocket has been inspected, or if you bring it to inspection in the afternoon and the winds pick up, it can be quarantined where it has to stay um, with the stay in a secure area, and then you will be the first ones on the rack in the morning. But I would try to plan as much as you can to fly in the morning before the winds pick up.
All right. Um, what else? All right. We have one more question regarding our. Wait, I'm sorry. This one's the eyeball that we have here is not really forged. It's just welded. Um,
Okay.
we bought this one here. Do you recommend that we really need to look for a forged one, or this will work?
I would need to look at the DTAG. In my opinion, a welded um, I I bolt, I nut, I bolt should be fine. Um, yeah, I don't know the answer to that. Um, it wouldn't hurt to have a backup, but again, I can see if I can find that out.
All right.
I do second that. I think forged eye bolts. I mean, if so long as he can close the gap, it should be able to work. Just I mean, double check the load limits, see if it gives you a good factor of safety at parachute deployment. Um, and I think it may be fine, but yeah, I don't have any strong red flags about it.
Anyway, think that would just be it for us. Um, yeah, that would be it for us.
How many people are coming to Irec?
There will be 13 students and then three mentors, and they all pre-registered, and we already have our visas. But
Okay, excellent. That's great. That's a good, strong team.
Perfect. Accepted.
Yeah, I think that covers up on the IREC side. I think we'll have some more questions. So just keep in touch if we have further questions. I think, especially on the launch site and the convention center. But
Okay,
yeah, I think we are good. We'll just update if we have more questions and if we do changes uh, with our techniques. But we're taking notes with what was discussed today, and I think yeah, that's pretty much it.
okay. All right, sounds good. I think you guys are ready. There's a few things to work on or have as backups, but I think you're good to go.
Okay, Bob, would you be good with us having to take a picture with you?
is it
It's
okay?
just a screenshot.
Sure.
Sure, yeah, it's for our university
Maybe
requirement.
maybe the others could also turn on their cameras, just so. All right.
Noah,
Uh,
picture.
Can I ask you what VMAX motor you flew?
It was a K. Well, at the time I was told it was a K 1965, and I don't know. I don't think that's the same anymore. I don't know what if Triple E motor testing changed that.
I see.
Yeah, it went 0 to 619 miles an hour at 48 feet.
That's
It coasted
crazy.
coasted to 13,000 feet. It's like a long cannon blast. It was pretty crazy. It was a free motor. I didn't know it was going to go that high.
Pre VMAX.
Yeah, yeah, that was Paul Robinson was still there. Well, no, he was on.
Let's have the countdown.
all right. 3, 2, 1. Okay. Just one more. Uh, 3, 2, 1. All right. I think that would be it. Thank you so much.
I think my eyes were closed, but that's okay. No.
Thank you.
Good luck. I hope to see you in Texas.
Accepted.
Thank you,
See you
Bob.
also.
Thank you, Noah.
Thank you.
Good luck
Be
with your
speaking with y'all
See you,
soon.
Noah.
Thank you, Noah.
Thank you, Bob.
Have a good one.
Good job, guys.